friends, this is Mainak from Civil Center and I welcome all of you back to another video tutorial on Tekla Structural Designer. So friends, in today's video we'll see how to do the interactive design of beams in Tekla Structural Designer. So basically in the software we can do the structure analysis, but how to change the sizes of the reinforcement and the number of reinforcement, how to control the sizes of the members in terms of beams, we'll see that in today's video. So without wasting any time, we'll get started in the software. So now, as you can see, we have this particular building model which has been opened here. Now I can go to a particular level. Let's say I'll go to this level and I'll select this beam. This beam has a size of 50 to 350. I can do the interactive design of this particular beam. I'll just right click on it and then I can do it. Select here the option of interactive design static. So after we do this, as you can see, we have 4 spans of the beam. So the 4 spans are named in order of 1, 2, 3 and 4. That is from bottom to top. Naming has been done. So it's important to understand the naming. So now the first span, we have the reinforcement of 12 mm and 16 mm in the top portion. So 2 bars of 12 mm and 2 bars of 16 mm has been applied in the top portion. So now, as you can see, there is a ratio which indicates whether the design will pass or fail. If we just, you can just change this. So this ratio is 0.233. If we just change this to 16, you can see this changes to 0.132. So it's more safer. So if you just do it 8 mm reinforcement, it fails. So like this, you can do the interactive design. So here I'll keep it as 12 mm because default size, minimum size, I want to keep as 12 mm. Let's see if it goes safe by 12 mm or not. So the ratio is now, as you can see, the HT required to the HT provided ratio is your 0.278, and if I do it as 12 mm, so it will be within the limits. So we can provide 12 mm reinforcement as well. So 4 bars of 12 mm in the top and 2 bars of 12 mm in the bottom. Like this, we can also change the spacing of the links or the stirrups also. Let's say we can just do it as 200 and 200. We can do like this, and this is the going back to the longitudinal bars in the second section. As you see, this bar 6 right is automatically taken, and in your bar 6 left, right portion of the previous beam is taken in the left portion of this beam. This is automatically done. And here let's just check the ratio of the second zone of the top, that is 0.217. So now HT provided is much more, as you can see. If you just provide 2 bars of 16 mm, let's see whether it will be sufficient or not. 2 bars of 16 mm we have provided, and it is sufficient for taking the HT. So if you just make it 12 mm also, so then also it will be sufficient. So we can provide 4 bars of 12 mm in the top. We can provide 2 bars all through and 2 bars as extra. So this interactive design is very useful if you want to do the detailing and structural design. So here also in the bottom bar we have a ratio of very high ratio of 0.053. So in the bottom bars also I can do it 12 mm first, and the ratio is kind of balanced now. If you give 2 bars of 12 mm, let's see, you can take the 2 bars of 12 mm. So then also the ratio is good. So like this we can change the design, and if you want to the structural design, if you want to save the cost of the steel, this is very helpful. So now this beam, so we have options of this left, which is automatically taken, and bar 5 we can change this bar 5. Let's see if you provide let's say 12 mm reinforcement here, what is the change we observed in the second portion. 12 mm reinforcement, as you can see, this has failed. In 10 mm reinforcement, in 12 mm reinforcement, this passed. So we can provide here like this, and the top also for bar 1 right, if we just provide this 12 mm reinforcement, it will do. So and also reduce the number also. Let's check. So after reducing the number, it has been failed. So let's just make it a bar of 16 mm, then it will pass. So 2 bars of 16 mm and 4 bars of 12 mm we can give to the members. 2 bars of 16 mm we can take as all through, and 4 bars of 12 mm we can take as extra near the supports. Similarly, we can do similar things for your longitudinal bars bottom as well. As you can see, this is E1, 2, 3 for the longitudinal bars bottom, and you can change this. So this particular bar 10 we can change. We don't need so many reinforcement, I think. Let's just change it to 12 mm bars, 2 numbers, let us first give, and see changes. So 2 numbers, it's okay with 2 numbers of bars. Here also bar 7 also. Let me do this as 12 mm bars of 2 numbers. It is safe. And bar 9 also will do as 12 mm bars of 2 numbers. So it is also safe here. So like this, we can do the interactive design. And going to the last span, we have 4 bars of 16 mm on the top. The ratio is 0.416. So we can, let's see, if we just take 12 mm bars, the ratio will be 0.624. AST required is 141 and AST provided is 226. So it's sufficient. Here also we'll do as 12 mm bars. Now, so 12 mm bars needed to be provided, 2 bars of 12 mm. If you provide along the top span, so then it is sufficient. 2 bars of 12 mm also if you provide, then it is sufficient for that portion. And in the bottom portion, we need 2 bars of 12 mm. AST required is 93 mm square and provided is 226 mm square. So this is the interactive design in which you can make certain interpolations, and then you can just check your structural design using it. You can make it safe. You can manipulate with the sizes, and we had also made a video on interactive design of columns. You can find the link in the description below, and keep watching our channel. And if you want to have watch more such videos, stay tuned to our channel and keep commenting. And if you learn advanced design using Tekla Structural Designer from us, you can register using the link below or drop a message with WhatsApp. We also have many other courses included in Civil Center Student Club. You can join them also. So stay connected, guys. See you. Bye bye.